Hi everyone, my name is Neha, and in this video, I'm going to show you how to find the LCM and GCF of a set of numbers. Let's get started. First of all, what does the LCM and GCF stand for? Well, the LCM stands for the least common multiple and GCF stands for the greatest common factor of a set of numbers. We will first start with the GCF, or the greatest common factor. Our problem we have over here says that we must find the GCF of 40 and 15. So, the first step to find the GCF of 40 and 15 is to prime factorize both of the numbers. What does it mean to prime factorize a number? Well, when we prime factorize a number, we have to find which prime numbers we have to multiply together to get the original number. There are two methods to prime factorize a number. The first method is called the tree-factor method, the factor tree method, and the other method is called the upside-down division method. I will demonstrate both of the methods in this problem for 40 and 15. Let's first start with the factor tree method for 40. So, I'll first start by putting 40 over here, and then I'll list out two factors of 40, which could be 2 and 20. I can't reduce 2 any further, but I can reduce 20 again into two factors, which could be 2 and 10. I can't reduce 2 again because it's already a prime number, but I can reduce 10 into two factors, which could be 2 and 5. Now, I can't reduce any of the numbers anymore because they're all prime. So, now, that tells me that I've prime factorized 40. So, the prime factorization of 40 is equal to 2 times 2 times 2 times 5. Next, I'm going to do the upside-down division method for 15. So, what you do for the upside-down division method is you put 15 over here, and then you divide 15 by one of its factors, which could be 3. 3 times 5 is equal to 15. The only other number we can divide 5 by is 5. So, 5 divided by 5 is equal to 1. So, the prime factorization of 15 is equal to 3 times 5. The next step is to look at which factors are common between the prime factorizations of 40 and 15. The only factor that we see which is common between 40 and 15 is 5. So, the GCF of 40 and 15 is equal to 5. So, the answer to this question is 5. Now, we'll go with the LCM, the least common multiple. Our problem says to find the LCM of 24 and 36. Just like we did with the GCF, our first step is to prime factorize both of the numbers, 24 and 36. Now, what I want you to do is pause the video and try to prime factorize 24 and 36 by yourself. Okay, I'm going to demonstrate once again both of the methods that we learned in the GCF problem, the factor tree method and the upside down division method for both of these numbers. So, I'm going to start with the factor tree method for 24. So I'll put 24 over here, and I'm going to split 24 into two factors, which could be 2 and 12. Now, I can't reduce 2 any further because it's already a prime number, but I can split 12 into two factors, which could be 2 and 6. I can't split 2 or divide 2 any further, but I can divide 6 into two factors, which could be 2 and 3. So, the prime factorization of 24 is equal to 2 times 2 times 2 times 3. Next, I'm going to show you the upside down division method for 36. So I have 36 over here, and I'm going to divide 36 by one of its factors, which could be 3. So 36 divided by 3 is equal to 12. Next, 12 divided by 3 is equal to 4. Now, 4 divided by 2 is equal to 2, and finally, 2 divided by 2 is equal to 1. So, the prime factorization of 36 is equal to 3 times 3 times 2 times 2. So, I'm counting all the numbers on this side over here. Now that we've prime factorized it, the next thing we're going to do is we're going to find which factors are common between both of the prime factorizations that we did for 24 and 36, just like we did for the GCF problem. Now, we see that 2 is common between both of the factorizations and 3 is common between both of the factorizations. So what you're going to do is you're going to do 2 times 3. Next, you want to look at both of these numbers, 2 and 3, and see the most number of times they occur in both of these prime factorizations. We see that in the first prime factorization, for 24, we see that 2 occurs 1, 2, and 3 times. And for 36, we see that 2 occurs 1 time. So the most number of times 2 occurs is 3 times. So I will do 2 to the third power. Now for 3, I see in the first factorization, which is the factorization for 24, I see that 3 occurs 1 time. And for the prime factorization of 36, I see that, the 2 in the prime factorization for 36 occurs 2 times, not 1 time. For the prime factorization of 36, I see that 3 occurs 1 and 2 times. It occurs twice. So I will do 3 to the second power. Now you want to multiply this out. So 2 to the third power is basically 2 times 2 times 2, which is multiplying 2 into 3 times, which is equal to 8. Remember, this is different from 2 times 3, which is equal to 6. Over here, we're doing 2. So we're doing 2 times 2 times 2. Similarly, 3 to the second power is equal to 3 times 3. So we have 8 times 9, which is equal to 72. So our answer is 72. Thanks for watching this video, and I hope you liked it. Please subscribe to this channel and click the notification bell so you don't miss any more updates on this channel. Bye!